Effective error handling is a critical aspect of writing high-quality code. In this video, we'll go over the top best practices for error handling using JavaScript. Without any further ado, let's get started. Use exceptions rather than return codes. In programming, when a function is called, it is expected to either return a value or indicate whether it has completed successfully or not. Traditionally, this has been achieved using return codes. However, using exceptions instead of return codes is a better approach to error handling. For example, this function returns a Boolean value to indicate whether the number is even or odd. However, if the number is not a valid input, there is no way to indicate this using a return code. Instead, we can use an exception to handle this case, as shown in the following example. In this example, we use an exception to indicate that the input is not a valid number. This makes the code more readable and easier to maintain. Use try-catch blocks to handle exceptions. When an exception is thrown, it needs to be caught and handled appropriately. Otherwise, the JavaScript file fails to continue executing. One way to handle exceptions in JavaScript is by using try-catch blocks. A try-catch block consists of two parts, the try block and the catch block. The try block contains the code that might throw an exception, and the catch block contains the code that handles the exception. When an exception is thrown inside the try block, JavaScript immediately jumps to the catch block to handle the exception. The error object that is thrown is passed as a parameter to the catch block so that you can examine the error and take appropriate actions. In addition to try-catch blocks, there are several other ways to handle errors in JavaScript: promises, callbacks, event emitters, and return values. While try-catch blocks and promises are the most commonly used ways of handling errors in JavaScript, it's important to be aware of these other techniques and use them when appropriate. Provide meaningful and informative error messages. When an error occurs, it is important to provide clear and informative error messages along with the exception. This can help developers and users to understand the cause of the error and take appropriate actions to fix it. For example, consider the following code that attempts to read a file from disk. If the file does not exist, this code will throw an error. However, the error message provided by Node.js is not very informative and does not provide any guidance on how to fix the problem. To provide a more informative error message, we can customize the exception message, as shown in the following example. In this example, we customize the exception message to provide more information about the error. Now, if the file does not exist, we get a more informative error message. Don't return null. In JavaScript, returning null is a common way to indicate that a function did not produce a valid result or that an error occurred. However, this can lead to unexpected behavior and errors in the code. One issue with returning null is that it can be easily forgotten to be checked in the calling code, resulting in unexpected errors or bugs. For example, if a function that is supposed to return an array returns null instead, and the calling code expects an array, it may try to use methods on null, which will result in a runtime error. Instead of returning null, it's recommended to throw an exception. Throwing an exception with a descriptive error message allows the calling code to handle the error more effectively. For example, instead of returning null in getAllUsers function, we can throw an error with a descriptive message. Don't pass null. In JavaScript, passing null as a function argument can also lead to unexpected behavior and errors, just like returning null from a function. If the function expects a certain value to be passed as an argument and it receives null instead, the function may not work as intended and produce errors or unexpected results. To avoid this, a best practice is to use default arguments or object properties to handle missing values instead of relying on null. This makes the code more predictable and easier to understand. For example, suppose we have a function that takes an object and performs some operation on one of its properties. If the property is missing or has a value of null, the function will throw an error. Now, if the obj argument is not provided or is undefined, an empty object will be used as the default value. This ensures that the function won't throw an error when obj.property is accessed. Use logging thoughtfully. Logging is an important tool for diagnosing and fixing issues in your JavaScript code. By logging errors and debugging information, you can gain insight into what's happening inside your code and track down the root cause of issues. First, let's create a logger function that logs errors with time and error in a file. We can use Node.js built-in file system module to write to a file and console object to log errors to the console. This function takes an error object as a parameter and uses the toLocale string method to get the current time in a readable format. It then constructs an error message string with the timestamp and error message, followed by the error stack trace. The function then writes the error message and stack trace to a log file using the append file method, which appends the content to the end of the file. If there is an error while writing to the log file, it logs an error message to the console. Now, let's say we have a function that performs some operation and may throw an error. To handle errors and log them appropriately, we can catch the error and call the logError function we defined earlier. This will log the error message and stack trace to both the console and a log file along with the timestamp. Use specialized exception. The next best practice for error handling is to use specialized exception classes to communicate the specific type of error that has occurred. Using specialized exception classes can make it easier to handle and diagnose errors, as well as make the code more readable and maintainable. Here is an example of how to use specialized exception classes in JavaScript. In this example, we have defined a database error class that extends the built-in error class. This allows us to create a new instance of database error and pass in a custom message when we encounter a database-related error. By doing this, we can communicate the specific type of error that has occurred in a clear and concise way. Using specialized exception classes can also help with error handling, as we can catch specific types of exceptions and handle them in a specific way. For example, we could catch a database error and display a user-friendly error message to the user while logging the full error details for debugging purposes. In this example, we use the instance of operator to check if the caught error is an instance of the database error class. If it is, we display a user-friendly error message and log the full error details. If it is not, we display a generic error message and log the full error details. This allows us to handle different types of errors in a specific way, which can improve the user experience and make it easier to diagnose and fix issues. Document your exceptions. It is important to document the exceptions that your functions and methods can throw. This helps in better understanding the behavior of the code and handling the exceptions in a more effective way. You can use JSDoc annotations to document the exceptions that your functions can throw. Here's an example. In this example, we are adding throws with type error and a descriptive message explaining when the function may throw an error. Use finally blocks for cleanup. The finally block is a section of code that is executed after the try and catch blocks, regardless of whether an exception was thrown or not. It is typically used for cleanup operations, such as closing a file or database connection, releasing resources, or resetting variables. If an exception is thrown within the try block, the catch block is executed to handle the exception. After the catch block, the finally block is executed. If no exception is thrown, the finally block is executed immediately after the try block. Here's an example of using the finally block to clean up resources. In this example, we open a file using the openFile function. And then we log the file content using the readFileContents function, which returns the file content. Finally, we close the file in the finally block, regardless of whether an error occurred or not. By closing the file in the finally block, we ensure that it is always closed, even if an error occurred while reading from it. This helps prevent resource leaks and ensures that our application behaves correctly under all circumstances. And that's it. These are some of the best practices for error handling in JavaScript. Don't forget to like and subscribe to the channel for more videos like this. See you soon.